So in the previous videos, we have completed the most important topic, that is the precipitation from the hydrology. Okay. So coming back to the original slides or the initial slides of this chapter. So in the initial lectures, we have seen about the definition of hydrology, that defines the study of hydrological cycle. So in this hydrological cycle, we have studied precipitation. Okay. So what is the meaning of precipitation? Then what are the forms of precipitation? What are the types of precipitation? Okay. Now, after the precipitation, the other components of this hydrological cycle has to be studied separately. Okay. So now from this lecture, we are going to start the first important, or we can say after precipitation, the next important one, that is evaporation. Okay. So we are going to start about evaporation. Now before starting it, let's write down one flow chart here. So precipitation. Okay. So that is input to the hydrological cycle, correct? So this precipitation is, or it happens in the area which we call it as catchment area, correct? Now from the catchment area there is, or we can say there are certain other processes which takes place. And if I just mention these processes, then they are interception, or we just starting right, if we start writing it from the evaporation, then it will be evaporation. Okay. Then transpiration, interception, then infiltration. Okay. Sometimes this evaporation and transpiration, or we can say this evaporation and transpirations, they are combinedly studied as evapotranspiration. Okay, in short form, ET, evapotranspiration. So the input to the system, or the input to the hydrological cycle, is the precipitation. Okay, that is the rainfall. So once this rainfall occurs in the catchment area, there are certain catchment losses. Okay, or we can say these are the losses which takes place. Now what are the various losses? So the losses are given here, that is evaporation, transpiration, interception and infiltration. So these are the losses which takes place. So once all the losses are taken out from the system, then the final product that we get is called as a runoff. Okay, so this runoff is also called as net rainfall, or rainfall excess. Okay, so these all terms are same only. So as we can see that the input to the catchment is precipitation and the output to the catchment is runoff. These all the intermediate processes are the catchment losses. So now up to now we have studied this precipitation, how to measure precipitation and other things. Okay, now we are going to start the catchment losses. That is, we'll start from evaporation, then transpiration, interception and infiltration. Once we get the precipitation, or once we understand precipitation and the losses, then we can get the value of runoff. So let's give the heading as catchment losses. Catchment losses. So in this, the first one that we are going to study, it is evaporation. It is evaporation. So what is the evaporation? It is the process of conversion of liquid to gases. So process of conversion of liquid into gases. Okay, so this process is called as evaporation. Now the rate of evaporation depends on following characteristics or the following properties. So what are those? The first one is vapor pressure. The first one is vapor pressure. So in this, write down the rate of evaporation. The rate of evaporation ROE is proportional to difference between saturation vapor pressure difference between saturation vapor pressure. It is denoted by EW, and actual vapor pressure. Okay, so if you just write it down, it will be rate of evaporation EL. It is proportional to difference of saturation vapor pressure minus actual vapor pressure. So if we remove this proportionality sign, then it will be EL is equal to some constant value into EW minus EA. This is called as Dalton's law. See, these kind of questions will be asked in the exam. So this Dalton's law of vapor pressure, it is related to what? So that can be asked, or it can be asked like in the evaporation or the rate of evaporation, according to Dalton's law, the rate of evaporation is proportional to, it is proportional to saturation vapor pressure, it is proportional to actual vapor pressure, or it is proportional to difference between saturation vapor pressure and actual vapor pressure. So this you should know. Okay, so this is the first factor on which the rate of evaporation depends. So vapor pressure. Now the second one is the temperature. So the rate of evaporation increases with increase in the temperature. So it is directly proportional to temperature. A rate of evaporation increases with increase in temperature. So this is the second factor. Then the third one is wind. So how the wind affects the rate of evaporation? So if the wind speed increases, that is we can write the rate of evaporation increases with increase in wind speed. Okay, next parameter is atmospheric pressure. Atmospheric pressure. So here one thing you should understand is that if you go from Earth's surface to higher altitudes, that is increase in altitude will lead to decrease in pressure. So increase in altitude increase in altitude will lead to decrease in pressure. Decrease in pressure. So that means if you are standing on ground, okay, and then let's say you are moving by using some lifting device, you are getting lifted up, okay, and you are present at this point now. So what is happening to the pressure? With the increasing altitude, there is decrease in the pressure. The pressure decreases as we move up above the surface. Okay, so increasing altitude will lead to decrease in pressure, and decrease in pressure will lead to increase in evaporation. Increase in evaporation. So that means if we increase in altitude, or if we just go from earth's surface to higher altitude, then the rate of evaporation is more, or it increases. Then what about the water quality? So that is the next property, water quality. So a rate of evaporation decreases, a rate of evaporation decreases by 1%. Okay, it decreases by 1% for every 1% increase in every 1% increase in salinity of liquid. So in this case it is water. So if the salinity of water increases by 1%, then rate of evaporation decreases by 1%. So these are the major factors which are affecting the rate of evaporation. So this can be asked in the exam, like what is the relation between rate of evaporation and vapor pressure? So it is given by the Dalton's law. If it is asked about temperature, then if the temperature increases, then there is increase in rate of evaporation. Similarly, if wind speed is more, then rate of evaporation is more. See, the opposite is there also. Okay, I have given it only increase, like rate of, in case of wind, it is rate of evaporation increases with increase in wind speed. So rate of evaporation will decrease with decrease in wind speed. So that much you have to gauge it yourself now. Okay. Similarly, the atmospheric pressure and water quality. So if you are just getting confused about what is the vapor pressure, so you can just understand it like this. If this is a bowl of water and we are boiling it, okay, we are providing it heat, then what happens? The water will evaporate. Okay, so the water molecules now will be converted into gases, and the gases concentration will increase here. So what will happen is these gases will apply certain pressure to the surface of the liquid here. So this pressure which is applied by the vapor is called as vapor pressure. Okay, so we don't have to go much in detail about this. So this much things is sufficient for it. Okay, just remember the Dalton's law and the other parameters, and how the rate of evaporation gets influenced by the parameters. Okay, so that's it with the evaporation basics. Now in the next lecture we will see how to measure the evaporation, that is methods of measurement of evaporation.